Hello, dear students. Let's come back to the topic of ambiguous grammar that we were seeing in the previous video, and let's see some more examples of ambiguous grammar. Remember, CFGG is said to be ambiguous if there exists more than one leftmost derivation, rightmost derivation, parse tree for some string W, at least one string W, which is recognized by the given grammar. That is, it is element of LG, language generated by the grammar. Let's take an example. We are given this set of productions, that is, we are given a CFG. Notice that these are three productions read as S derives AS, or this symbol is or, remember, S derives A or S derives epsilon. And we are asked to derive a string, just a small string, A. Now, what are the possibilities? Let's try LMD for this. First thing we can try is S derives AS. So we are using the very first production given, and that's it. We have got this A, the very first A we needed. And in the next step, we can replace this S with epsilon. We are using the last rule given, S derives epsilon. And you can very well see that the string A has been derived from the given grammar. But then the same string A can be derived in one more way. You can say S derives A and the matter ends A is derived. You can see that S directly derives A, isn't it? But both these, this LMD, this leftmost derivation and this leftmost derivation, or rather both derivations, are valid because they derive the string A from the given grammar, but the steps are different. For the same string word W, you are getting two leftmost derivations. Now, same thing is applicable for parse tree. Of course, if more than one LMD exists, then more than one parse tree exists, because parse tree is nothing but representation of LMD or RMD in the form of diagram. So what will be the parse tree for this derivation? We started with the start symbol S, and then we used the production small a, capital S, and finally we replaced this S with epsilon. So we got a leaf A and leaf epsilon, which means we have a string A, small a. But what about this derivation? We started with start symbol S and S directly derived A. That's it. We have got our terminal string A, which is the desired string, isn't it? That's it. If you are able to find out even one such word for which more than one parse tree or more than one LMD or more than one RMD exists, then stop it and say that the grammar is ambiguous. Okay, let's take one more example. Imagine that we are given a grammar as E derives E plus E or ID. Now listen here, this plus is a terminal symbol and ID is a terminal and E is a non-terminal. Don't forget, grammar G is collection of four things, NTPS. Here, the non-terminal is only one non-terminal, as you see capital E, this is the variable, and two terminals are there, which are plus and ID. And the production P, this production P, we have been given two productions. This is the first production, E derives E plus E, and this is the second production, E derives ID. And the start symbol, of course, is E. Now imagine that we try to derive a word something like ID plus ID. This is the string containing all terminal symbols. You will see when you do LMD for this particular string, you will get only one LMD, unique LMD you will get. And then you would say that anyway I am getting only one LMD, so this grammar is okay, it is not ambiguous. But it's not so easy. I was telling you in the previous video that maybe for this string you got unique LMD, you are not getting two different LMDs, but there might exist a string that has two LMDs if you use this grammar. Let's prove ID plus ID is very nice. way we can show as E derives E plus E is the first production, and then this E is replaced with ID plus E remains, and finally this E is replaced with ID, and we got the desired string. You can watch that there is no other LMD possible for this. Every time we have used the leftmost non-terminal and we have replaced it first. Okay, but now just imagine for the same grammar, I'll rewrite the grammar. E is E plus E or ID. Just imagine we are given a word as ID plus ID plus ID. This is the string. Now, the derivation should start with E, and we will use E is E plus E. Now, let's say that we are using LMD, leftmost derivation, and this leftmost non-terminal is replaced with ID in the next step. So this plus E remains. Now you watch, for the given string, we have got ID plus. Check this. The prefix ID plus, we have already got it. But now we need the next part is ID plus ID. This portion we need. So what we will have to do is this E will have to be replaced with its option, and option is E plus E. I hope you are understanding. And then again, because we are using leftmost derivation, E is the first leftmost non-terminal. Now we can replace this E with ID because E derives ID plus E remains. And finally, the last E remaining can also be replaced with ID. Fantastic. So we have got our string ID plus ID plus ID using the given grammar. But now you see one more LMD exists. We can start saying E is E plus E as usual, as we said. And then how about replacing this E with E plus E? Check that E derives E plus E, isn't it? Why don't we use that production over here, and then plus E as you see remains here. Now using leftmost derivation again, this leftmost E replaced with ID plus E remains. Again leftmost derivation, this first E from the left replaced with ID, and last E remains, and then finally last E replaced with ID. So we have got our desired string. You observe. What is more important to see here is that for the same string and the grammar, there exist two LMDs. You can see this was the step one, where this was the step one. Okay, step one matched. Step two did not match. Step two are not matching. You can see here this first non-terminal was replaced with ID, but here the first non-terminal was replaced with E plus E. Although both derivations are valid because both are deriving the string, but important thing is two LMDs exist, so the given grammar is ambiguous. What is most important, is that when you started testing this grammar was given. When you started testing it with this string, you saw that only one LMD exists. So don't be in a hurry. You find out a string for which there might exist two LMDs, and we found it. The string was ID plus ID plus ID, isn't it? So these were two more examples of ambiguous grammar, and I hope you have gone through the definition and you understood it completely very well. Thank you very much.